we know that a derivative is just the slope of a tangent line to a function at any given x value. But how do we actually find the derivative of a function? Well, let's just say we have some function f of x. All right, we'll call this our x-axis and this our y-axis. I'm going to draw a function f of x in blue. So we're going to say f of x looks something like this. All right, pretty much looks something like this. So this right here would be our function f of x. Now remember, the whole idea of taking the derivative of a function is that you're finding the slope of a line tangent to the function at any given x value. So if we were to just choose any point on f of x, for example, let's just say we choose this point right here, then this point, it could have any given x value because we're choosing any point. So we're just going to say the x value of this point is x, right? That means the y value of this point would be f of x. So the idea is we need to find the slope of the tangent line through this point. And that would represent the derivative of f of x because it's the slope of a line tangent to this function at any given point. So how do we actually do that? How would we find the slope of this tangent line? Now, you may not know how to find the slope of a tangent line, but we do know how to find the slope of a line between 2 points. So let's just say we have another point on f of x, and we're going to say that point is right here. All right, and we're going to say that this point right here is at this x value. And we're going to say that the distance between these 2 points is h. That means that the x value of this point is x plus h. That means the y value of this point would be f of x plus h. All right, and the line that goes, pretty much the line that goes through these 2 points, I'm going to make it in green, and it's going to look something like this. All right, going through these 2 points, it would look something like that. So it's the line going through those 2 points. And we actually have the ability to find the slope of this line because we know the x and y value of this point and the x and y value of that point. So we actually have the ability to find the slope of this line. So let's do that. And we know that the slope of a line is just change in y all over change in x. Right? And we can, of course, apply this idea here. The slope of this line, well, the change in y is just f of x plus h minus f of x. And the change in x would just be x plus h minus x. Right? And notice how x, we can do x minus x is 0, and we're left with h. So I'm just going to rewrite that as h. All right, so we're going to rewrite that as h. So this right here, pretty much this would be the slope of this green line that goes through these 2 points. So how could we find the slope of the tangent line then? Well, what if we let this point right here get closer and closer to our original point? So we let this point get really, really close to this point. Well, if that happens, then this green line that we made through those 2 points, it will get closer and closer to the tangent line, right? Because these points get closer and closer together. So really, when these points get closer and closer together, h is going to approach 0, because remember, h represents the distance between the points. And so really, when we decrease the distance between those 2 points, h is going to approach 0, and the green line that goes through these 2 points is going to get really, really close to the tangent line right here. And so once they approach 0, pretty much we get the line tangent to this, pretty much at this point. So really all we have to do is take the limit as h approaches 0. And so that'll let these points get really, really, really close to each other. And so the green line pretty much becomes equivalent to that of the tangent line. So really, all it is pretty much taking this slope of our green line that we found here and letting h, right, the distance between these 2 points, approach 0. So really, all it is the limit as h approaches 0 of f of x plus h minus f of x all over h. And so this right here, I'm just going to erase just a little bit of this. I'm erasing the x-axis, but pretty much this idea is super important. It's the derivative of a function as a limit. This is the whole big idea of what a derivative is. It's pretty much that idea. And so this is the idea of pretty much, this is like the rate of change, but when we take the derivative, the distance between these points becomes really, really, really small. And so we think of this as the instantaneous rate of change of f of x. And that's the whole idea of a derivative and how we can find the derivative of a function.